The critical distinction is, when do they cross paths? Now, this is a tricky subject to answer because you have to know certain things about time zones and latitude and latitudinal points. Now, if you look at the various areas of the globe cut up by the Tropic of Cancer and the Tropic of Peppercorn, you'll see that there are only two distinct regions where there's only one distinct region actually where the two intersect. And when the two time zones intersect, because they only exist in one time zone at a time, the area where the two time zones intersect is directly south of the Tropic of Peppercorn in the area known as South Ecuador.
Oh my God.
Now, in South Ecuador, there is an area where both time zones collide at the same time, and both areas of time are possible at the same time. In a sort of, at which point one would have to go faster than the speed of light in order to accurately accomplish this. One would literally be going interstellar.
You have to re-explain Will's question about where a nutrient would go.
Yeah, because they're in the same time zone. If a nutrient gets a nutrient infestation, what kind of doctor does the nutrient go to?
Now, this is an important question. Where would an ent go? A nutrient specifically? Well, they go to an entomologist, obviously.
Yes.
That is ridiculous.
I know.
That is so cool.
You'll probably never hear anything more amazing. It's an entomologist.
So we moved on from there.
The person who studies insects.
Perfect. So from there, we moved on to the topic of 12th century communes in Indonesia, which is next to Fibulasia.
Oh my God. We just never ended.
From there, we discussed the evolution of the saltine and how it originally came from the merging of the anchovy with the piece of bread, which created, for a very brief period of time, this can only be measured in jodoseconds, the concept of the anchovy sandwich, also known as the infinite saltine paradox. We also had a brief aside to talk about.
Ned, you should be a professor.
Huh?
Oh, just wait. Salty. It has to do with being salty.
Yeah, I'm pretty salty.
Did you just get those shoes?
Wait, you're...
No.
What?
I'm on there.
Nikhil, a study in blood science.
Yeah.
Oh, okay.
Now, often two synonyms used together are blunt and blatant, but I've just decided to combine the words to create a more, efficient sort of communication. So we're going to start calling it blunted from now on. There we go. We also had a brief aside about the origins of Four Loko in the Mexican-American War and how it helped win the war for the Mexicans.
What about next week's lecture? You were going to explain.
Oh, next week's lecture on blunt science?
Yes.
Okay.
I need a discussion. This is confusing.
We
Office,
have a lab.
office hours are going to be every Tuesday and Thursday at midnight.
They gotta sign up for it.
Blunt force science is where science is literally like forced in
Into you.
into your mind.
Like that. So we got blunt force science.
You can get blunt force trauma from blunt force science.
We decided that Ned could easily walk into a classroom as
In
long
Elm?
as Will was in the audience and no one would question
Oh
anything.
my God. No, but guys, imagine this, walking into an Elm classroom where there are people doing homework, like we come in with notebooks, Ned just starts like lecturing and
You know what?
like
You just need to find an ideas professor that's late and walk in and say, "I'm the substitute. Here are some ideas that change the world."
You guys have a hard time keeping your straight faces, though. You just start dying.
You do it really well.
He does. Everybody else does.
So does Will.
Crack up.
So, can anyone tell me the key principles of blunt force science?
Seriously, be my professor, man.
I would definitely attend your class.
Okay, thank you very much.
I would
I would fight you, Will. I'm kidding.
I
for
am
that
actually,
last spot.
With
I-
your blunt force study.
I am actually a accredited professor by
Do you have
Macmillan
tenure?
Higher Institutes.
Did you?
I don't know. The email is pending. You think this is a joke? It's actually in my notes.
Oh my gosh, you're right!
I am actually a professor according to the context book.
Ned McCormick.
I may have sort of misled an economics website to make them believe that I'm a professor.
Where did you graduate from? Interstellar University?
Story.
Actually, University of Phoenix.
No wonder. What's the story behind that though?
I was trying to sign into my econ textbook, and I went to the wrong website.
Oh,
And they wanted me, and it was accidentally the instructor's website. And I signed in. They asked for an email, and so I gave them my email. And they're like, "Okay, sure. So what are you?" And I said, "I'll be a little bit generous. I'm just gonna say I'm a TA." They sent me an email back addressing me as Professor McCormick.
Oh my god.
So I've got all the credentials I need.
High school diploma. Check.
Professor.
Check.
Yeah. So can anyone tell me the primary principles of blunt force science?
Rolling the fat one.
Any takers?
Rolling the fat one.
Okay. Good one. Rolling a fat one. Can anyone tell me what the one is?
I'd rather not.
That's fine. I'll get into it anyway.
One of those raps I have.
Now the fat one is actually a person.
So what do you take them up to the orchard? That one. You could get blunt force.
I mean, putting it bluntly, yes.
Oh my god. The amount of puns going on right now is blowing my mind.
So, what are the other principles of blunt force science?
I have a question.
Huh?
Is the fat one have any relation to Joey Fatone of what is it, NSYNC or?
Ah, that's an interesting corollary. Talking about.
What? No, it's once in 6 months now.
So here we have the fat one,
Can I say,
which may be equal to Joey Fatone.
force equals mass times acceleration. So what is the mass of the fat one?
Huh?
Force equals mass times acceleration. So we're looking at what's the mass of the fat one.
The blunt force equals.
I'll be back in a bit.
So we have F equals MA. So blunt force, or BF, is actually equal to mass of fat one
Not to be confused with BS,
That's the
which is blunt
acceleration
science.
of the rolling!
times the acceleration of the rolling. Right there.
It makes so much sense.
That is your primary blunt force equation. You will want to take notes. This will be on tomorrow's quiz.
Can we do an example?
Sure, here's an example problem right here. So we're just going to get rid of this cake and Greek letters. Because
Fuck the Greek letters, I'm so done with those.
No, we are done.
okay, so let's take an example. Now, you're up at O Hill, so specifically O Hill. Okay, so you're up in O Hill at a height of approximately 91 meters from sea level. Now, this is not in normal meters, this is actually in English meters. English meter being approximately 78.5% of the normal meter. Now, there we go. So meter English, which is equal to meter normal times 0.785. So, bearing in mind that we're going to be using English meters for this, let's say that the fat one specifically has begun rolling down the hill. Now, we assume that they have no initial acceleration when they begin rolling down the hill, because no one wants to deal with that. And they have no friction, because this is in fact an introductory blunt force science class.
Wait, you eliminated friction?
I did eliminate friction.
Yeah, if you take the upper level 300 courses.
If you take advanced blunt force science, we will deal with both rolling friction and static friction when dealing with rolling a fat one.
What if I want to get a BBS degree, Bachelor of Blunt Science?
Now, if you want to get a BBS degree, that's going to take approximately 4 to 6 years. Depending is how long it takes you to roll a fat one. Fat ones can take anywhere in the proximity from 9 to 13 metric months.
Can
Or
you show us a
MM.
proof?
Proof of what? The length of rolling a fat one?
Yeah.
Okay. So, we'll do that one right over here.
My example.
Okay, we'll get back to the example in a minute. So, here's the proof.
Oh.
So, rolling a fat one, not a simple thing. So, you've got your constant of rolling, which is going to be approximately, let's say, 0.78. We've already used 0.78. Use 0.18. So you've got a constant of rolling, that's 0.18. You've got the constant of fatness.
Why isn't it 0.42?
Well, the constant of fatness is actually 0.42.
Wait, is it
0.
Isn't
The
the
0 is important because we're working
Isn't the fatness a
sig
derivative?
figs.
Fatness is a
Good.
derivative because it changes depending whether you go to Burke or Ham.
I like that. It's also dependent, you must remember, on location, specifically which dorm. Now, you've got a number of dorms. You've got Southwest.
Well, the O hill
And that's
fatness
it.
coefficient will be lower than the other groups.
No, but it's higher.
At O hill, no, they have to climb.
No, it's higher because of, show them why it's higher.
No, the constant of
It's
fatness at
higher
O hill-
because it's blunt force science.
Yeah, no, but we're talking about the constant.
Well,
of
if we're
fatness.
talking about blunt force science, the leaders in innovation
Because it's higher.
are coming out of Central
Yeah,
mostly.
so they have to talk.
No.
I see what you did there, Ned.
So, working with our constant of
So
fatness.
wait, how high on O
Sig
Hill
is
are we?
420 in sig figs. 0.420 specifically. Sorry?
How high on O Hill are we?
Approximately
So high.
9 meters.
approximately 71 English meters.
Okay.
Right.
Oh, is that sea level or hand level?
It's actually from Hampton level, which is 3 feet below Hamp level.
Ham?
Hampton.
Hampton.
Hampton
Yeah.
level.
Where's Hampton?
It's right next to Ham. And Burke.
In
Hamden.
between.
Hamden.
Hampton.
Hampton.
Okay.
I like that.
They don't sell ham.
They do not. And why do they not sell ham? Because they'd be infringing on the patent rights of the saltine,
It is.
which has exclusive rights to salt.
It's called the Ham Den.
Yes, the ham den, because they've been storing faux ham as they can't use actual ham, as that would violate the salt treaties that we discussed earlier.
So what are they
So where
using
does
the
that
faux
leave
noodle
pigs?
Wait, then what's in Lunchables? I was like convinced it was
What's in what bowls?
Lunchables.
Lunchables. Now, Lunchables, you get a lot of complex carbs, nutrients, etc. going into a Lunchable. But the primary ingredient of a Lunchable is neither the carbohydrates nor the nutrients, but it is in fact the tomato sauce. Now, tomato sauce, or TS, is actually the 85th element on the periodic table. Does anyone know the atomic weight of tomato sauce?
Yeah, I was just gonna ask you that.
Okay, that's fine. I got you right here. It's 131.
How many electrons in its outer shell?
Sorry?
Electrons in its outer shell?
And its outer shell is 4.
What?
Just 4.
It's about the shell.
Can you draw us a Lewis structure of a Lunchable?
No, it changed. Are we talking nacho or the ham and cheese ones?
So, if you got a Lunchable here, now let's say you've got, so a Lewis structure is going to look something like this. So you've got a map, and here's Clark over here. Now, here's Lewis,
Does Clark have a structure?
and the Lunchables are in fact here.
Okay.
As you can see, they are exactly equidistant from both Lewis and Clark. Why is this? Because they're not very good at packing. So,
What is the charge of a Lunchable?
the
Is it-
charge
is
of a
it
Lunchable
negative?
is about $1.50.
So it's negative. When you expend, it's negative.
Yes, the charge is in fact cost. It is not in what some may call volts or coulombs, which are actually a bastardization of the phrase cool limes.
Wait, is a Lunchable an element? Is it ionized tomato sauce?
Tomato sauce is an element. A Lunchable is a combination of various elements such as tomato sauce and carbohydrates and nutrients.
Tomato sauce is an element.
Are
Tomato
those,
sauce is
are
my
those
favorite
all?
element. Oh yeah.
Are none of those ionized? Or are
That's
they
great.
just regular, like?
Ionized. That's a good question. Are they ionized?
Well, wouldn't that make Lunchables a neutral charge if they weren't ionized?
They're not a neutral charge.
Oh.
As proven before, they do have a definite charge.
$1.50.
And that charge is $1.50. The charge is $1.50. Specifically. Good. Okay. So
So
Other
they're
questions?
an economic liability.
They are an economic liability, and that's why NASA is attempting to send them into space right now to separate them from the human population.
And do you agree with that politically?
Do they convert sunlight in space into some sort of energy? Do they act as solar panels?
Okay, I'll answer
Does it
those two
split?
questions separately because we have a political and a biological question here. So, politically, the concept of sending Lunchables into space has been long debated by the human population, specifically President Nixon.
Do they have a conscience or not?
Guys, we're overwhelming Professor McCormick with questions.
So, because of this, due to the recent amount of scandals surrounding current President Nixon over the Hoover Dam scandal, there has been a lot of questions as to whether or not we should believe this certain charge that he's made.
Watergate.
The charge specifically being he made a charge of approximately $5, all of which was expended on NASA research to attempt to find the solution to the removal of the Lunchable problem. So, it's a complicated issue with many factors, as you can see. Now, in terms of the potential chemical properties of Lunchables, now, you were talking about their ability to reflect sunlight and absorb sunlight. They've actually been proven to be a perfect white body conductor. Now, a white body conductor is something that is able to reflect all energy given to it. So, because a Lunchable is a perfect
That's a
white
black
body
body.
conductor, well, a black body conductor absorbs all energy that comes to it. A white body reflects all energy that comes to it.
Gray
Therefore,
body.
huh?
Gray body.
Gray body is everybody. Exactly. So, a perfect white body is able to reflect all energy that comes towards it. And in doing so, it is able to reflect all of the light energy, including
That would
all
make
of...
it a star.
No.
Not quite. It's reflecting all of the light energy, all of the microwaves that hit it, specifically the GE brand microwaves
Wait,
that
so
are
you
launched
can't
into space every
microwave
once in a while that reflect off of it. Now, you're talking about turning it into a star. Now,
Wait, so you can't microwave a Lunchable?
Can you make an array of Lunchables to focus the reflected energy to accomplish a task?
Is it possible to program a Lunchable?
Could you take an array of Lunchables and focus them on like an asteroid that is going to hit Earth? Could you save Earth with Lunchables?
now, the
This is
question
what the tomato sauce element allows us.
that really comes to the core of this is, are Lunchables trustable? Do we trust the Lunchables?
Are they trustables?
Trustables? Are the Lunchables trustables? So we're just going to erase this part about Jody time.
If you put a Lunchable in outer space, it becomes a launchable.
Well, I believe it was launchable as soon as it left the ground. So, now the potential to create an array, specifically an array, of Lunchables is tricky. Because Lunchables are very difficult to control. Now, Lunchables behave very similar to electrons. No one knows where they are or how fast they're going at any point in time. If you try to find more about one, you'll find less about that one as well. So the more you try to find about the speed it's going, the less you'll know about the speed it's going.
So wave particles
So
gravity.
They
So-
like to run through the system like diarrhea.
Now this comes from Mossberg's.
Isn't that a gun?
Yes, uncertainty principle.
It's a gun.
Now, Mossberg's uncertainty principle stems from the Mossberg shotgun because nobody could tell if it was loaded or not. It was very dangerous. It was outlawed in the 1700s. So,
You couldn't tell because it was covered with moss, right?
yes, it was actually the first
Wait, I thought it was covered
biodegradable
with
shotgun invented by Moss. It just sprung up out of the ground. Biodegradable shotguns. We were very grateful for them for a very short period of time during the steel shortages of the French and Spanish War. Now, also known as the 12 Years' War in America. So, back to the Lunchable uncertainty principle. So, because we can never know the speed or the location of a Lunchable, it was obviously very difficult to get them off the ground. But all we needed to do was figure out where the Lunchable wasn't, and not launch that off the ground. So, the solution, in essence, was to launch all of the contents of the Earth off the ground. Save a very brief portion. Now, the way we were able to do this is through, you were discussing the particle wave duality.
Yes.
Is through the gravity duality, in which Nosferatu, specifically, because he is the master of all switches, flipped the switch. Now, Nosferatu flipped this proverbial light switch, which was also an actual light switch, and turned off gravity.
So there's duality in that too.
There is. There is an on button. In this process, we were able to remove all Lunchables from the surface of the Earth and send them into space, along with the rest of life on Earth. But we got those damn Lunchables out of there, so it was worth it. So, any more questions?
Why are Lunchables not safe for Earth?
Ah, yes. So, despite the fact that Lunchables can neither be found or their speed quantified, they are also aggressive. Now, they've been...
In reflecting microwaves.
They reflect microwaves, which can be a huge hindrance on the microwave throwers of the Detroit population. Now, it is a local pastime in the culture of Detroit ever since the 1200s, this being AC.
Could you just not move so fast?
No. Ever since 1200 AC, which was the period after cooling.
Show you how it's videotaping it.
After cooling.
Don't worry, you will catch up.
Ever since 1200 AC, the population of Detroit has been very, very concerned about microwave throwing. Much in the way of Irish log throwing, the population of Detroit has avidly been following microwave throwing. They would throw all kinds of microwaves, GE, Hess, Walmart brand, anything they could get their hands on. The last being the easiest kind. So, because they were throwing all these microwaves around, they were actually generating large amounts of profit for the city of Detroit through various microwave attendance throwing sales. As such, the city of Detroit became the most prosperous and rich cities in all of the world.
So the Lunchables
So back to the Lunchables.
having microwave reflecting qualities.
Now, because the Lunchables have microwave reflecting qualities, they were able to reflect all thrown microwaves by the denizens of Detroit. Now, this obviously put a large damper on their primary export, which was microwaves. Specifically microwaves that they had thrown. As a result of this, the economy of Detroit plummeted to the point that we know it today.
And we know that Lunchables
in
are
which year-
liability because they're a charge.
Because they had a charge, a specific definable charge of $1.50.
So not only did they charge Detroit, but they also reflected the main economy of Detroit, which was throwing microwaves.
Yes. The main economy of Detroit was in fact reflected, like a light wave, onto the city of Anchorage. Now, Anchorage didn't really need the economy, but they received the economy anyway through a light wave. Now, as the light wave of economy, now as we can imagine, this is a rainbow.
Professor McCormick, can I just ask a question before you move on?
Yes.
You were saying that Lunchables were hard to study in terms of knowing where they were.
Yes.
Is that because they reflect brainwaves whenever you try to think about them?
One second.
Take that as a yes.
Okay, so here we have a little bit of demonstration about what happened to the economy of Detroit it was in fact reflected by a Lunchable into the city of Anchorage. That's
As for the brainwaves question,
This is well-established science. So,
are we still on blunt force science?
I think this is all one.
we are very peripherally related to blunt force science.
Peripherally?
So, what can we do? Indonesia. Okay, so. Okay, so the question was brainwaves. Now, brainwaves are a very interesting topic. Now, brainwaves have a very similar property to what?
Microwaves?
Anyone tell me? Close? Anyone?
Nutrients.
They have a very similar property to rain waves.
Oh, of course.
You mean they share 4 of the characteristics?
Yes. They specifically share the fact that they are wet, that they travel in packs, that they are around whenever loud noises are around, and that they are wet. Now, much like brain waves are triggered whenever moisture enters the head in a pack. And this is often stimulated by loud noises, such as bang, crackle, or snap. So, moving on from this, we see that, and they are in fact very wet. So, a brain wave can travel through the air like a cloud. And as such, it is reflectable by a Lunchable, because a Lunchable is able to reflect all different kinds of energy. And clouds are in fact a form of energy, especially when they are charged by the brain waves. How much is this charge? It's about tree fitting.
Damn you, Loch Ness Monster.
This charge is about tree fitting. Okay. Does that answer your question?
Sort of. I mean, I'm trying to understand, because we've been thinking about Lunchables right now.
Yes.
So that means we have been sending these clouds,
Yes.
and they've been bouncing off Lunchables.
Yes.
What is that? How does that affect what we've been thinking?
Now, because of the Mossberg uncertainty principle, we are not able to be certain of what we in fact just discoursed. None of this could in fact have been what we suspected it to be. And everything written up there might just be Greek. In fact, for a brief period it was Greek. And then it was erased. But, due to this specific uncertainty principle, we are unable to be certain of the brain waves that we emit, because they're so moist, and because they can be in fact reflected by Lunchables. And due to the uncertainty principle, we can never know where a Lunchable is at any point in time.
Professor, I think it's time for office hours.
Why, yes, it is. So,
Can
that
I
will
just
conclude
say
class.
Thank you for making
Yes.
yourself perfectly clear.
That's what I try to do. Thank you, thank you.
Great lecture.
Okay, so I'll be writing up my office hours and location on the board up here.
At Massachusetts General Hospital of Entomology. I'm just reading your shirt now at this point.
Yep.
I actually remember this information more than
Yeah, it's really
I know,
sad.
like a regular lecture. It's kind of weird.
Now, it says 12 o'clock, that's because it doesn't matter. I repeat.
So it's just 12 o'clock.
Well, I mean, as we learned about with merging time zones, they do in fact interact depending on the Mayan calendar that you happen to be using. Because there are multiple interpretations of the Mayan calendar, both the Julian and the Jamesian.
James Bond?
James Joyce.
Oh, okay.
James Bond is a different calendar only used by the Scottish.
Where's your office?
Yeah.
Oh yes, I should mention that.
And what's your email? What email can we reach you at?
Oh yeah.
Can you post a link to your online textbook?
Yep.
Oh, I was gonna go to bed.
Does the
Yeah.
Ned, does the owl page live in the nutrient?
Or the nutrient?
They're coming.
And there's my cell in case anyone wants to reach me. It's on 86753.